we were surprised to see that they can outperform in electromagnetic interference shielding all other known materials. But then we found that in epidermal electronics, they can outperform gold just because not being more conductive, but having a lower impedance with skin and tissue, they can enable all epidermal electronics people have been talking about.
I'm super excited to have you and get the chance to interview you. So I'm Shubhadeep. I'm the Academic Partnership Liaison at XPANSE, and it's my absolute pleasure to have you with me. So to begin this interview, let's introduce you to the guest. So how would you introduce yourself in a sentence?
Well, I'm a professor of material science and engineering and director of the Drexel Nanomaterials Institute at Drexel University in Philadelphia in the United States. And I'm a material chemist, material scientist. We discover and explore new materials.
So as a fellow material scientist myself, this is something I've been dying to ask you. So I'm going to go straight to that. So you gave the world the gift of MXenes. So what is something that you saw it being used in that surprised you, the creator who didn't think that MXenes could be used in this certain field?
Well, when we discovered MXenes, we knew from the beginning pretty much that these materials will have a future. And there are several reasons. One, it's a very large family of materials. So we were quite positive that at least some of them will find application. Second, they have very unusual properties. They are metals, but metals that can be dispersible in water. Right after drying, forming films with properties that differ from properties of graphene or other 2D materials. So, and more we research MXenes, more surprises we get. For example,
so I recently read an interview you gave to Nature about how you stumbled upon MXenes. So do you mind sharing that story in short for our viewers?
Well, many scientific discoveries are made, as people say, by mistake. So it's basically serendipity. When one works at the border of unknown, goes into terra incognita, there is always a probability to find something new. And we do research, but we observe not only what we want to see, but also something eventually unexpected. We were working on developing materials, anode materials, for lithium-ion batteries with my colleague, Professor Michel Barzoum at Drexel University. And our goal was to introduce lithium into layered ceramics known as max phases. However, lithium refused to go into the structure and bind with silicon in the interlayer of the ceramics. So what we try to do is to use a method that my group has been exploring for about 30 years now, selective etching, to make room for lithium ions to get into the layered structure consisting of carbides layers and layers of so-known A element, like silicon, aluminum. And a PhD student working on this project, Michael Nagib, tried many different approaches until he found that hydrofluoric acid decomposed, pulled apart titanium aluminum carbide, making two-dimensional sheets. Initially, we assumed there were graphene layers. My postdoc who looked at them found two-dimensional layers and told me, Yury, that's graphene. But when we look more carefully, we realized this was titanium carbide, two-dimensional titanium carbide seen for the first time, not predicted theoretically to exist, not expected. And this is how MXenes were born. And now we have more than 50 basic compositions, dozens of solid solutions and other materials, and the family of MXenes keeps growing, and the number of applications keeps growing too.
Perfect. I love this story because it signifies how important failures are. Like, we think that if our experiment is gone wrong, that's the end of the world, but who knows what new beginnings it brings. So I think we're coming to a close, so I would like to end with one last question. So imagine you're given a book with all the secrets of the universe. What are the two chapters that you're going to skip to immediately at first? So what are the two answers you want about the universe?
This is an interesting question. As scientists, we are trying to uncover the secrets of the universe. And pleasure is really often in discoveries, not to cheating, not to getting them, not to necessarily reading about the secrets. But if I could get access to secrets of the universe, I would probably try to use them to establish two things. Ensure that we have a healthy environment that humans can enjoy living on the planet Earth and not necessarily escape or go interplanetary not because we have to, but because we want to explore further. And second, find a way to establish peace on planet Earth. Like someone coming from Ukraine, a country which is torn by war now, I really wish peace to all people in the world. And I think scientists should contribute to both solving environmental problems and also establishing understanding between people around the world so that we can all coexist peacefully on a healthy planet.
Yes, absolutely. Super agree. And I think I really hope that science brings people together instead of dividing people, and it leads us to a healthier, happier, peaceful life for on Earth.
I think that's why we all are at this conference, in this wonderful meeting, bringing together people from pretty much all over the world.
Exactly. So with that, I would like to end this interview. Again, it was an absolute pleasure to get the opportunity to interview. I really enjoyed it, and I look forward to seeing you again.
Thank you very much.